Now that we have these two methods for solving problems with similarity, I want to give you another example, and I'll show you both methods and how you can use them to solve other problems. So in this case, we have a poster that is 2 feet wide and 4 feet long. The poster has a simple design on it that you would like to scale up and draw on a larger poster. And by the way, this is how actual artists do this. Mural artists, for example, do this all the time. So here on our larger poster, we want it to be 6 feet wide now, and we want to know how long will the poster be. So let's use first our scale factor, and then our internal factor methods. So the scale factor, what the scale factor says is we have 2 feet wide and in our small poster, and we want it to be 6 feet wide on our large poster. So how do we get from 2 feet to 6 feet? We have to multiply by a scale factor of 3. So if we have a 4 foot long poster, then we have to multiply by the same scale factor to figure out how long our poster should be. So in this case, our poster would be 12 feet long. So that's using the scale factor. Let's see if we can do this in a slightly different way with the internal factor method. Now for the internal factor method, we are going to set up a proportion, and we want to compare 2 feet wide. I like to break everything out, so not just the numbers, so I can make sure I'm matching up the correct parts of my proportion. 2 feet wide and 4 feet long. Then I know that I have 6 feet wide, so my feet wide have to go together. So I have to put my 6 feet wide on the top, and then my question mark on the bottom. Now that I know I have it set up correctly, I can now cross multiply. So now I can leave off the extra words and just say 2 times question mark equals 4 times 6. Or 2 times question mark equals 24. Divide both sides by 2. And my question is 12. Now I can add back in my units, feet long. So 2 different ways to think about solving problems with similarity, but we end up getting the same answer for both parts of the problem.